Hey everyone! Today, we're going to pull back the curtain on one of Python's most powerful and sometimes tricky tools, the while loop. If you've ever needed a program to just wait for something to happen or repeat a task an unknown number of times, well, you are in exactly the right place. So here's our game plan. We'll start with the absolute basics, what a while loop even is. Then we'll get our hands dirty and build one. We'll talk about the dreaded infinite loop trap and, more importantly, how to avoid it. After that, we'll see these loops in action in the real world, and finally, we'll put for loops and while loops head-to-head so you'll always know which one to grab from your toolkit. All right, let's kick things off. First up, what exactly is a while loop? Let's break down what it does and what it's made of. At its heart, a while loop is really just driven by a question. Before it runs even once, it asks itself, is this condition I'm watching still true? If the answer is yes, awesome, the code inside runs. If the answer is no, the loop just stops. That's it. That's the core logic. And the structure itself is, honestly, beautifully simple. You've just got the while keyword, then whatever condition you're checking, a colon, and then your block of code, all nicely indented underneath. And that clean syntax, that's one of the things that makes Python so awesome and easy to read. Okay. Now, to build a loop that actually works and, eventually stops, you need these three key ingredients. First, you initialize a variable before the loop. Second, you check that variable in the condition. That's our gatekeeper. And third, this is the most important part, you have to update that variable somewhere inside the loop. If you forget that last step, well, you're going to have a bad time.
Okay, section 2, enough theory, right? Let's actually put this into practice and build our very first loop.
So check this out. We can see our three key ingredients right here. We initialize our count variable to 1. Our condition, the gatekeeper, is checking while count is less than or equal to 5. And then at the very end, we have our update, count plus equals 1. That little line is what moves us one step closer to finishing the loop each time.
And here's what you get, a super clean output. The loop prints the number, then it increments the count, and it just repeats that process. The second count becomes 6, the condition count less than 5 is no longer true, and the loop stops, exactly when we wanted it to. Perfect.
All right, now we've got to talk about something super important. This is easily the biggest mistake people make with while loops. I'm talking about the infinite loop trap. And this question gets right to the heart of the danger. Think about it. If your loop's condition is always true, why would it ever stop running? The short answer is, it won't. And here is a textbook example. We set x to 1, and then we tell the loop to run as long as x is equal to 1. But we never change x inside the loop, so that condition will always be true. This thing will just print, I am stuck, over and over, kind of like a digital hamster wheel, until you crash your program. But don't worry, Python gives us a couple of get-out-of-jail-free cards. The break and continue keywords give us fine-grained control from inside the loop. I like to think of break as an emergency exit and continue as a shortcut to the next lap. Let's look at break. Here, it's our escape hatch. Even though the main condition says to run until num is 10, we have an if statement that says, hey, if num equals 5, hit the brakes. And bam, the loop stops dead in its tracks. That's why the output only goes up to 4. Now, continue is totally different. It doesn't stop the whole loop. When num hits 3, the continue keyword basically tells Python, hey, forget about the rest of the code in this round, just jump straight back to the top and start the next one. In this case, it skips the print command, which is why the number 3 is missing from our output. Okay, so this is all cool in theory, but where would you actually use a while loop in the real world? Let's look at a couple of scenarios where while loops are the absolute perfect tool for the job. This is a classic. You need to keep asking for a password until the user gets it right? The thing is, we have no idea if that's going to take them 1 try or 20 tries. A while loop is perfect here, because it just keeps watching and waiting until that condition, the password being correct, is finally met. And it's the same idea with something like a menu program. The whole point is for the program to just sit there and stay active, waiting for you to tell it what to do. The while loop keeps it running and processing commands until the user specifically types exit to make the condition false and break the loop. All right, for our final section. To really become a pro at loops, You gotta know when to use a while loop and when to use its popular cousin, the for loop.
This table really lays it out. The big idea is this. For loops are for when you know how many times you need to loop. You're working through a list or a range of numbers. It's definite. A while loop is for when you don't know. You're just waiting for some condition to change. That's why the analogy of a counter versus a watcher is so perfect. So, if you remember one thing from this section, let it be this mental model. A for loop is a counter. You use it when you have a specific number of items to get through. A while loop is a watcher. You use it when you're just watching, waiting for something to happen, like a user typing something or a value changing. So here are the simple rules of thumb to follow. If you're working with a list, a string, or a range of numbers, grab a for loop. It's almost always the cleaner, safer choice. If you're waiting for some condition to change, especially user input, that's a job for a while loop. And of course, always double check that your while loop has a way to end. Honestly, it all boils down to this one simple quote, and it's brilliant. Choose for when you know how many times to loop, and while when you don't. If you just burn that sentence into your memory, you will almost always pick the right tool for the job. Happy coding!